Hello guys, this is a video to show you how to use the bonus formulas to solve the exercise number 2 because it's an exercise that we have done during the class and we did these procedures in the last session. I think that I had a mistake in this and I changed it because the answer 17.7 times 2 is 35.4. And in this exercise, it's exactly the same exercise, but again, with these formulas, given that they are suitable for what is being asked for. So let's read the problem number 2 again. It says, a projectile is launched with a speed of 220 meters per second and with an angle of 52 degrees. In this case, they are asking in question A, time to maximum height. Then in question B, they are asking for the time, sorry, for the maximum height itself. And according to the bonus formulas, we can use this one. And its maximum height equals to the initial velocity in the y-axis square divided by 2 times the acceleration. And you may remember that the acceleration in the y-axis is 9.8 meters per second square. Something that I want to mention is that in this formula, acceleration will be positive, and in this formula as well, acceleration in the y-axis equal to 9.8 meters per second square, and here it's also positive. You will see why in a moment. Let's try to substitute the values. It will be equal to initial velocity in the y-axis square, and that's initial velocity times sine of the angle. Initial velocity 220 times sine of 52 square divided by 2 times 9.8 meters per second square. Here we will use gravity as a positive number because if you use it as a negative, the maximum height will be a negative number. Try to solve this and see if you have the same answer as with the previous procedures. Max height equal to 220 initial velocity times sine. Check that you are using sine of 52, the angle of the launching angle, square, and that must be divided by 2 times 9.8. And I got 1533 meters. And that's the same maximum height as with the previous procedures here. Then the question C is asking for total flight time. So the total time from the end to the beginning. And that will be given by this formula. Minus 2 multiplying initial velocity times sine of the angle divided by acceleration in the y-axis. Here, the acceleration will be negative. It will be minus 2 multiplying 220 sine of 52. And that divided by minus 9.8 meters per second square. And this, I got, well, try to do it. Try to do it. I'll give you a moment. Remember, this is the total time. And if you remember, the time to the maximum height is located at the half. So it will be the half of the total time. That's why we are calculating total time and first, and then we will divide it by 2 to get the time to the maximum height. Do you have the answer? I got 35.4 seconds. And that's the exact same answer as in the previous procedure. And then you divide that by 2.4 divided by 2, and that's equal to 17.7 seconds to the maximum height, just as in the previous exercise. And finally, the letter D, and it is, according to the book, the maximum range. The maximum range is given by the formula initial velocity squared times sine of 2 times the angle divided by the acceleration in the y-axis, but in this case, positive. Why? Because if you use negative, the distance will be negative, and that doesn't make sense because this distance is being positive. So it will be initial velocity 220 square times sine of the angle 52 times 2. All that divided by 9.8 meters per second square. And this, please try to calculate that number. In this case, we may have a slight difference, but it's given by the decimals that we are using. And this is again the maximum range, the horizontal displacement, the total horizontal displacement. Try to solve it and see if you have the same answer as me. I got 4,792 meters. That is very similar to this, the one that we obtained in the previous exercise. Sorry. Um, Here. Again, this may be different because the decimals that we omitted and here, but it's almost the same. Additionally, you can use these same formulas to solve the exercise 1, the problem number 1 on page 108, and it says a projectile is fired at a speed of 50 meters per second. Initial velocity equal to 50 meters per second and an angle of 30 degrees. Again, I think that we have solved this using the other formulas. I don't remember actually, but I think that we have solved this exercise. Let me check. I don't know. We didn't. We solved the exercise number 3. So what you can do here is use the same formulas. Give me a moment and I'm gonna paste these formulas. And they are asking in the question A, the total flight time. So it will be total time, it's equal to minus 2 times the initial velocity, 50, multiplying sine of the angle, 30, divided by minus 9.8 meters per second square. Try to solve it, please, to see if you have the same result as me. I got 5.1 seconds. Then in letter B, the book is asking for maximum range, and that is given by this formula. Remember, acceleration in this case is positive, and it will be range, the horizontal displacement, equals to the initial velocity, 50 meters per second square, times sine of 2 times the angle. All that divided by 9 positive 9.8 meters per second square. Again, this is positive because if it were negative, the answer will be negative, and that doesn't make sense. Try to use the same arrangement in your calculator, because some calculators have struggles with the angle. That's why I prefer to multiply 30 times 2 and then get the sine of that, and then 50 square, multiplying all that and then the division by 9.8. And I got 221 meters. Check if you have the same. And finally, they said, okay, what's the maximum range? But now at 60 degrees instead of 30. And you may remember something. The range is the same if both angles are equal to 90. Probably you don't remember that, but maybe you do. And we check that in this slide. That the angles, if they add 90, they will have the same range. In this case, 30 and 60. So let's see if that's true. It will be the same formula, 50 meters per second square times sine, in this case 60 times 2 divided by 9.8 meters per second square. And yes, try to do it, but I got 221 meters. And that's it. That's it for this video.